Now that we are done on our first algorithm, let's now proceed to our second algorithm, the least recent used page replacement algorithm keeps track page uses over a short period of time. It will replace the page that has not been used for the longest time. Let's now have an example. Consider a paging system having capacity of 3 pages. The execution of a program requires references to 5 distinct pages P1, P2, P3, P4 and P5. The pages are executed following sequences. Let's now list the page sequence and in pages. And just like in FIFO, let's put the first page in first column. Then let's write down the first page into the second column just above the second page. And in the third column let's write all first 3 pages in ascending order. Just like in FIFO, we want to replace the page with asterisk with the next page, which in this case the 4th page. Then just copy the remaining pages from column 3. And we will move the asterisk to P2 cause it is now the first. Let's do the same in column 4 and 5. Since the next page that will be placed is the same as in the column, we will just copy the entire column and put hit to it. And we will fill up the rest of the column using the method that we used on the other columns. And then put fault at the rest of the column except the one with hit. Using the same formula in FIFO, we calculate that the page hit ratio of LRU counter is 10%, while the page fault ratio is 90%. Using the same given, let's use LRU algorithm stack. First thing first, write down the page sequence in the pages. Then we want to copy all the pages in the first row just beneath them. Let's now start mapping. Since there is already a page in the first column, let's start at the second one. We just want to copy the first page in the first column through the second column's second row. The same logic apply to the third column until 6th column. Since the both first page and 6 and 7 column are the same, we just need to copy the entire 6th column into the 7th column. We will also put hit in the 7th column. Then the rest will be done by the same as what we did in 3rd to 6th column. We will put fault in each column except 7. Just like in the counter, we will use the same formula in stack. And it turns out that the page fault ratio is 90%, while the page hit ratio is 10%. We will now head to our last algorithm, and that is optimal page replacement. The optimal policy selects that page for replacement that will not be used for the longest period of time. This algorithm, now let's have an example. Consider a paging system having capacity of 3 pages. The execution of a program requires references to 5 distinct pages P1, P2, P3, P4 and P5. Now let's solve the example using optimal page replacement counter. Let's copy the first and second page into out second and first column. The same as LRU in FIFO, we put the asterisk in the first page. But unlike in LRU or FIFO, you can see that the asterisk in the third column was shifted to the third page, not in first page. That's one of the difference between LRU and OPT. In the fourth column, the incoming page is already in the column 3, so we just gonna copy the whole column 3 to column 4. But observe that the asterisk is now in P2, cause P2 is now the third. We also put hit on the top of fourth column. We just gonna repeat the procedure before to the rest of the columns. We also mark fault on those that misses or did not hit, and mark hit on those wo do. Now using the same solution as before, we compute that page hit ratio of our OPT is 40%, while the page fault ratio is 60%. We are now done on our lesson about page replacement. I hope you learn a lot. Thank you for listening.
Created using Powtoon.